Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is continuing on our OEM-specific ADAS training, and this week it is on Toyota. So following along the same structure we used last year with our OEM-specific training, just overall training, and we're drilling down to ADAS. So like I said, Toyota is this week, and let's talk about what's unique. Some things aren't necessarily all that unique to Toyota, because they use the same stuff that most other manufacturers do. Maybe they're different brands of sensors, but they use radars, cameras, and ultrasonic sensors, just like pretty much any other manufacturer out there does. But what they use it for, they use the radar for adaptive cruise control, blind spot monitoring, and front and rear cross traffic alert, depending on how the vehicle is equipped. Cameras, they have front view, rear view, and 360-degree view cameras, bird's eye view cameras, some people call them, where you can see all the way around the vehicle. And then, of course, ultrasonic sensors for park assist. Now, another thing about Toyota is they're going to be very similar kind of across the board. Doing a camera on one is going to be pretty much like doing a camera on another one. Radar, same thing. Can be differences, and I'll show you some examples of where you might see some differences. Toyota really likes to do split years. So like halfway through the year, it was this procedure, and then the other half, it's this procedure. So you'll see that called out depending on what you use for repair information, but should be able to see that called out in your repair information. Because another example is, we don't talk about Lexus in this class, but they're very closely Toyota and Lexus related. And Lexus has, even on the same vehicle, it has just 2 different years, or two different split years. They'll have 2 different procedures to do the radar, right? So you always got to make sure you read through, and if you think just double check with the repair information. They are particularly picky about space and lighting too. So lighting here, you see right from Toyota there, it says entire target not illuminated. That would be bad. The camera will not be able to pick it up if it's not fully illuminated. Now, how do I know if it's illuminated properly? Well, there's a little apps you can get for your phone, like little light meters for photography. Same type of idea here. So we can see we got 31, 65, and 98. So that's a very well lit one, and that is a poorly lit one. And you can see with the camera picture anyways, doesn't look like a huge difference between those, but it's enough to not have it lit up. I remember I did one on a live stream one time, did a live camera calibration. And sure enough, one of the targets, which is kind of off to one of the sides, was just a little dimmer than the others, and it wasn't able to be picked up by the camera. So we had to go back and redo it after, but we just kind of had to get through the stream. But once we got done, we came back with a brighter light and lit it up, and it was fine. So just be aware, if you have challenges calibrating, that might be one of the challenges you have, is just having it well lit. Space-wise, too, we can see how this is in a well-lit shop, and it's decently far away. It's probably a good 5, 6, 7 feet away from the car. And that's just one of the camera targets there. You do need decent space. You need even more space when it comes to radar. So this is an example. It's a 5-meter by 6-meter box, so 16 by 20 feet. That's a lot of room you need in front of the vehicle to catch it, especially for radar. So here's an example of radar. This is in one of our facilities down in Arkansas. And there's the little triangle target for the radar. It has to be level with the radar sensor and all that. But it also tells you before you trigger the radar to move the rig out of the way because it's made of metal, and it reflect off the metal in the rig. And you need to have no metal behind it for a distance as well. So just be aware if you are going to do stuff like this. Some vehicles you drive down the road. In this particular instance, we're doing it in a shop, right? And sometimes you kind of have to do both. Also, I don't think it's terribly unique to Toyota, but it is one thing that Toyota has you do is you may have to put in input values with the scan tool. So I'll show you where that is in the scan tool. But distance from the ground to the target center, width between the targets, pitch of the offset angle, distance from the camera to the target, and input the size of the target as well. Once all that's in there, you hit OK, and then the procedure will continue. So there is a place in the scan tool where you need to add that in. And like I said, I'll show you that in a minute when we get there. But now let's do our case studies. So we took the same top 3 vehicles from last year when we did the Toyota OEM training. And we're going to break down what ADAS features these top 3 representative vehicles have. So 2019 RAV4. It has 3 radar modules. 1 in the front for adaptive cruise control, 2 in the back for blind spot monitor and rear cross traffic alert, depending on how it's equipped. 5 cameras. It's got the front view camera. It's up high on the windshield, and then 360 view. There's 4, one on each mirror, 1 in the front, 1 in the back. And then it has 8 ultrasonic sensors for park assist. So if we were to look at the front camera there and the radar, so the front camera, as I said, high up in the windshield, that's for traffic lane recognition, traffic sign recognition, lighting for adaptive lighting. And then we have the radar on the front, which is right behind the emblem on the grille. So if we look on the scan tool, we can see we have 9 different options when it comes to ADAS. So we got blind spot monitor, master and slave, front radar sensor, front recognition camera for lighting control and lane control. So these 3 are the front camera, just 3 different ways of accessing it. And then the front radar sensor there as well. So that front radar sensor has the option for alignment reading and for beam axis adjustment, which is how we're going to actually adjust that millimeter wave radar sensor that I have on the front of the vehicle. So if we go in there, it says the function is used to adjust the beam axis of the front radar sensor. Confirm the following conditions. You need to make sure that the vehicle is on a flat surface. No metals around the vehicle and on the surface. Tire pressure is a specified value because we want to make sure that it is level and correct. No people in the vehicle because it could be leaning to one side if there's somebody in the driver's seat. Vehicle needs to be stopped. And turn the engine and power switch on, engine off, ready off. Note the function uses the triangle targets. We saw that picture of the triangle target before. That's what it uses. And it also says that in the next screen, in order to perform this function, a target is needed. Set up the targets correctly with reference to the workshop manual or use an ADAS recalibration system like the TruePoint. Press next to start adjustment of the beam axis. Warning, the radar transmits radio waves during this adjustment. Ensure there's a distance of at least 20 centimeters or 7.9 inches between the radar and the body of any person because it's sending out radiation. We don't want to be too close to that. And then with the camera, we have our recognition camera target position memory. So that is what I showed you earlier where you have to input the different heights and distances and stuff. So it says this function is used to store the target and vehicle data. Set up the targets correctly with reference to the workshop manual or use ADAS recalibration system. Entering the wrong values may damage the system. Once values are stored, you will have to perform recognition camera axis adjust or faults may be stored in the system. So we'd go through there, we'd hit target height, we'd hit edit, type it in, hit the check mark. Distance between camera and target, same thing. Distance between targets, target size, pitch offset angle. And then it gives us this. So here's what you entered. Is that what you want? And you hit start, and it would go. It would say the recognition camera and target position memory test is completed. Next, you have to perform the recognition camera axis adjust. And then you would go in and choose that from the menu. And then it says, I use this function to adjust the recognition camera axis, set up the targets correctly with reference to the workshop manual, or use an ADAS calibration machine. Confirm the following conditions. Turn the engine power switch on and ensure those conditions are met before proceeding. And then you would go through and do as your repair information says. Rear radar, it's going to be similar. They're on the two corners there behind the bumper, as you can see. There's also a rear camera in this picture. But if you go in there, there's a couple options. One for customized settings, so that can change the like how much it beeps and things of that nature, how sensitive it is. And then there's also special functions. And one of those special functions is the beam axis setting. So place the reflector according to the position in the repair manual, and we'll show you do need a decent amount of room once we go into the repair information. Ignition on, blind spot monitoring main switch is on. Set up to target correctly with reference to the workshop manual. Use ADAS recalibration system. Failure to complete the test may introduce codes into the system. And then you would walk through as it says. 360 camera. This one's a little bit different than what we might be used to or what we talked about a couple weeks ago with Ford. On this one, there's a rear camera and then rear gate. Front camera is right below the emblem, so it's right below the radar. Then I have a camera in each mirror, which they stitch them all together, wide angle lenses, stitches them together in the software, and they go. However, if I go in with the scan tool where it says panoramic view monitor, which is what they call the 360 camera, we go under special functions. There's calibration information. And it says we need to carry it out using the vehicle, actually. So the panoramic view monitor calibration can be completed from the diagnostic screen of the multi-display assembly or accessory meter assembly, so the actual touchscreen on the vehicle. Please refer to factory service information for instructions on how to proceed with this calibration. Now, there are some targets and things that you need, but you don't need a scan tool to do it. The scan tool tells you how to do it, but you don't need the scan tool in order to actually perform that function. And then park assist is park assist. Ultrasonic sensors, there really is no calibration for those. It's either on or off, good or bad. There are some ways to test them, though. I'll show you that in a little bit when we go live on the tool. But as far as this vehicle is concerned, 4 in the rear, 4 in the front. All right, moving on to our 15 Camry. Next, representative. So it has 2 radar modules, and they're all both in the back. They're for the blind spot monitor. Also used for rear cross traffic alert if equipped. Front view camera and rear view camera. No surround view on this car. And it has 6 ultrasonic sensors. If we take a look, there's our high-mounted camera again. And the procedure is going to be pretty close to what we just did on the RAV. So lane departure alert would be my camera. And then we do the target and position memory and the camera axis adjust. So it's going to be pretty much the same procedure. Rear radar, both in the bumpers again. Both going to be a very similar proposition for that. So let's adjust the blind spot monitor beam axis. Please set up the reflector according to the position of the repair manual. Ignition on, main switch is on. Use this function to inspect the BSM beam axis. Also use this function before clearing codes C1 ABB or C1 ABC. So those are both chassis codes. And then we need a few things. This is the factory tool number. So the adjusting stand and the reflector, 10 meters of string, a string with a sharp pointed weight or plumb bob, 16 feet of measuring tape, etc. It's going to tell you how to do it. So the inspection area should be 9 meters by 10 meters. So 29 by 32 feet or 30 by 33 feet, I guess, would be the way to call that. No other objects other than reflector in the area and no people in the inspection area. Set up the target correctly where it tells you to do it or use an ADAS recalibration system. Failure to complete the test may introduce TTCs. Follow the procedure, place it where it needs to go. And then hit the button and it'll turn on the radar and then it'll bounce off. Hopefully, as long as we put the target in the right spot. And then it should calibrate. Park assists, that has 2 ultrasonic sensors in the front and 4 in the rear. And they also consider the camera kind of part of that too. Because it would come up on the screen in reverse, of course. Then we have a 2013 Prius, which is relatively old if you think about it, about over a dozen years old, but it still has some ADAS functions back in 2013. So it did have radar cruise, which the Camry did not, which was a 2-year newer Camry, by the way. And it has 2 cameras, a front view camera and a backup camera. So it's fairly simplistic, but it does have a fancy feature that the Camry did not. So here's my millimeter wave radar sensor assembly. So that is our radar. And if we look in here, we can see Cruise control radar, pre-collision 2 and pre-collision 1, those are all related to that radar. And then lane keep assist, which would be the high mounted camera. So beam axis adjustment again, except back in the day, back in 2013, they would call it a laser sensor, even though it's not really a laser. It's actually millimeter waves. Set up to target correctly, reference the workshop manual, or use the ADAS recalibration system. There's the special tools in the string and the plumb bob and the measuring tape again. And then we need to make sure it is level. So you're going to put a bubble level on it. Make sure there's no dust or foreign matter on it. And then you can adjust it with a screwdriver, kind of like adjusting a headlight. So it can kind of go side to side. And then we have the camera, high-mounted camera. So that's going to be the same thing, camera and target position memory. I can input the values in there if I need to, and then camera axis adjustment is going to be in there. Same situation as the other two. So those really haven't changed too much. There's a couple slightly different procedures, but by and large, it's pretty much the same. And then for the rear camera, it's going to be there, and no real calibration for that rear camera. It either works or it doesn't. So fairly simple. All right, let's go live. See what we can see. First one I want to do is the RAV. Okay, so if we come down here, we can see 9 different options for our ADAS: blind spot monitor, master and slave, front radar, clearance warning, front recognition camera for lighting control, recognition camera and lane control, panoramic view monitor, parking assist camera. But I could also go into service resets and relearn. If I have a tool with the service resets, I can come in here and I can go down to, say I wanted to calibrate the front radar. So I can go into repair information from here as well. Wave radar unit. Come in, go into remove and replace. And then here is an example. So of a split year. Right, so 11 of 18 through 2 of 19, it's one adjustment, and from 2 of 19 to 12 of 21, it's a different adjustment. So they made a running change in there somewhere. And it is, you'd have to read through the whole thing to figure out where the change is, but it's based on the build date of the vehicle. All right, so you want to make sure it's level. There's where the radar needs to go, and then we start measuring with a plumb bob and find the center line of the vehicle and make some measurements like this. Figure out where everything needs to go. So 9.84 feet is the distance there. All right, use some tape or some chalk. And then if it doesn't work properly, it'll give you an error code, and then it shows you how to fix that as well. And then on the beam axis, you can go in there and adjust it. It needs to be -0.5 to 0.5 a degree when it's correct. So you can see all of that. What if I wanted to do the surround view camera? While I'm in here, I'm going to my ADAS section. It'll load. There we go. So outside view camera system. And remove and replace. Actually, it's not in there. It's in here after repair. There we go. Calibration. So you can come in here and it's going to tell you here's where you need to have some markers. Cross-check markers. And have them on the ground. And that's how you're going to be able to calibrate the camera using the internal thing on the touchscreen. But you're going to have some markings on the ground, right? Strings and markers and stuff like that laid out. So it's kind of like how Ford did it. If you remember a couple weeks ago, they had this big tent looking thing that rolled down the side, but considerably lower tech, looks like. All right, bunch of strings, things like that. All right, so that's our 360. And then I could be in the scanner and do any of my functional tests. So beam axis alignment right there. Also on some brands, some vehicles, Toyota is included. We also have guided component tests for the components. of the ADAS. So if we go into driver aids and ADAS, you can see we have blind spot detection mirror indicator, blind spot monitor sensor, park assist. So the park assist module is just going to give us powers and grounds, basically. All right, no real way to check the parking sensor. But this is kind of interesting. So if you go into rear view camera and you go to the signature test, communicates over cam, but it also has camera signals. And if you have the camera lens uncovered, you should see something kind of wacky looking signal like that. And then with the camera covered, it should be a not so wacky signal. But I thought that was interesting how we have an example of here's what it should look like with the camera open. Kind of neat. You're able to actually see the stuff going on. All right. So that is the RAV. Let's go into the Camry. Okay. And in this case, blind spot master and slave, lane departure alert, parking assist monitor. So if we go into blind spot master, there's that customized settings I talked about. So rear cross traffic alert function, mirror indicator brightness, vehicle detection timing. So you can actually go in there and early, middle, or late, or only in the blind spot. And then, of course, the special function was I can go in there and do the access display and access adjustment. That's in there. And then for the lane departure alert, that's the camera. So there's that camera and target position memory. So you'd edit this. Hit OK. Just throw some random numbers in there right now. I don't know what to put in. There we go. So there's all my values that I entered. You'd hit start, and it would go in and store the values to the computer, and then you can go and do your calibration and have it calibrate properly, because every room's going to be a little bit different, right? And the target's going to be in a little bit different spot every time. So that's why you have to enter those values in. Is for that particular instance, and that's just going to keep running. So activate that again. Okay, and then the parking assist. Special functions, that's that calibration information again. So you can do that from the multi-display assembly. And that one doesn't have 360 cameras either. So that's for park. The beeping. All right. And then finally we'll do the Prius. Okay, cruise control, pre-collision 2 and pre-collision 1. So pre-collision 1 gives us seatbelt motor actuators. And then pre-collision 2 gives us our beam alignments and stuff, beam axis adjustment. And then we can also go into cruise control radar for that beam axis adjustment as well. So a couple different ways to get into it. I suppose it gives you different data in that case. Lane keep assist will be the camera. There's a camera access adjustment. Goes through a bunch of different. Oh, this just says because my registered values for the camera are not correct, so it'll fail before I even do that. So you'd have to put in the memory before you even do that, or it's going to fail. So good to know. Tells you that in the repair information anyway. And then if I did want to go into my repair information, camera. That's for the rear camera. And then calibration. With advanced park guidance. Have to do some more math. Put some more strings around the car. And walks through it that way. How much is a radar for one of these things, I wonder? Let's see. Forward-looking radar, parts and labor. Collision avoidance. $2,200. It's the same one. Yeah, $2,200 for a radar sensor. So you better hope that thing doesn't get in too bad of a collision if it gets in a collision, because that's not going to be cheap. No, it will not. All right. So that is ADAS on Toyota in a nutshell. Like I said, very similar. Like a camera is a camera is a camera is a camera, is a radar is a radar is a radar. Slight variances depending on the year, month of build. So I always want to make sure you check that build date, especially when you go in the information and see it. There was a time that I've seen where someone was using, we'll call it a competitor information system, not Shopkey or Mitchell, and they couldn't get it to calibrate, couldn't get it to calibrate, couldn't get it to calibrate. Come to find out, you look it up in Shopkey, it's got two procedures, because one is early and one is late production, and then the other system only had one of the procedures in there, and it was the wrong procedure. So make sure you're using good information from the manufacturer, so you can make sure you don't get caught up in any of that stuff either. Just make sure your information's good and you read through all the information. Even if you've done one, you want to make sure you read through it all, because it could be different depending on the production date. Right? So that is Toyota ADAS. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.